All right, so notes, dilation, and scale factor. Now, a dilation is a transformation of an object that produces an image that is the same shape as the original, but is a different size. This should sound exactly like when we did similarity. Okay, they're similar figures, same shape, different size. But we're going to be able to transform figures, okay, using what it says on number 2. It says the scale factor of a dilation is the number that describes the size change from a pre-image to its dilated image, okay? So the pre-image is the old original, and it goes to a new dilated image. Okay, we're going to need to know this words, old and new. Okay? Because I got a fancy way of remembering this. It's going to be good. Okay? So, off to the right here, K is going to be our variable. So instead of using X or any other letter, we're using K. K stands for the scale factor. Okay? So again, K means scale factor. So, over off to the left here, scale factor equals new shape over old shape. Okay? So, you're going to run into this situation where you're like, what goes over what when I make my scale factor? And I'm telling you, if you want to know the answer, then you have to know N over O. No. Okay? Does that make sense? So the new is on top, the O is on the bottom, N over O, no. Because if you want to know the scale factor, then you have to know N over O. Okay? So are you hearing me say that? So look at number 3. Given a dilation, the scale factor can be found by dividing the dimensions of the image, the new, by the dimensions of the original, the old. Okay? So new over old, N over O. If you do it the other way around, you will get it wrong, and it will be a sad day. Look at example 1. What is the scale factor of dilation from pentagon 1, original, to pentagon 2, the new? You always go, whenever you're going from something to something, you start at the old, you end at the new. So my old is my pentagon 1, my new is pentagon 2. Okay, this is my new. So here's the question. What's the scale factor? Is it 5 over 8 or is it 8 over 5? Because obviously those are the only two sides I have. They're corresponding. So how do I know my scale factor? I know it because I know okay, N over O. So my N side is 5. And then my old 8. Thank you. So N over O. N over O equals corresponding sides, 5 over 8. Good. If you put 8 over 5, wrong. Okay? 5 over 8. What is the scale factor of dilation from? Now notice this. They're getting tricky. From 2 to 1. Now they're saying, what if we go the other direction? What if we change this to like that? Well, guess what you do with the fraction? Flip it, right? So the new is going to be 8. Sorry, N over O, 8 over 5. Do you see how it depends how they word it? What to what? New to old, and then you put in the sentence, you always start original to new, okay? O to N, and then you write the fraction as new over old, okay? So, if the scale factor is greater than 1, then your figure gets larger or smaller. So think about it. Greater than 1, larger or smaller? Big, larger, right? You could say bigger, but I think larger is a better word. So it gets larger if your scale factor is greater than 1, and then your scale factor is between 0 and 1. What kind of numbers are between 0 and 1? What's it? Tell me a number between 0 and 1. 0.5, meaning a decimal or even a fraction. Okay, so fractions, decimals that are less than 1, it's going to get smaller or shrink. Okay. So, example 2. Under a dilation, the picture shown at the right has been reduced in size. What scale factor was used in the reduction? Okay. So the picture was what? It says reduced. So which one of these is the original if it got reduced? Okay, the big one, 48 inches. So I'll put this is my original. So that means that this is my new one. You gotta label O and N first, okay? Doesn't it make sense if it got smaller, the original's big, the new one small? And now I'm gonna make my fraction for scale factor, new over old. So that's gonna be what over what? 12 over 48, which reduces to 1 over 4, which is 0.25. Fractions are cool, just saying. Number 5, once you've found the scale factor, you can find the lengths of the other sides of your shape by applying it, okay? Which is another way to do it besides doing proportions and doing cross multiplying and dividing, okay? So, for example, 3, now, TBH, I would just, if I were you, I would just use cross multiply and divide, okay? But I want everyone to see this example 3. Does everyone see how example 3, these two figures, they are similar, but it's been rotated, right? Like here's AB, but on the top, but here's AB on the left side, okay? So 4.6 corresponds with 11.5, right? And then, if AD is 12, BC is also 12, right? So BC and then B prime C prime, those are corresponding as well, okay? So again, it's been rotated, but what do we do when we have these similar figures? We set up two fractions, and we cross multiply and divide, okay? So let's do that. 4.6 over 11.5 equal sign, and then what over what? What do you think? If I did this over this, what's the other one going to be? 12 over x, okay? Cross multiply and divide. 4.6 times x is 4.6x. 12 times 11.5, okay? 138. Thank you. What do you mean? So Ms. Marrero is asking if we just eyeballed it. So we saw that AB has to match with AB, right? So it's been rotated in red, and then the blue ones, BC, those match up, so it's been rotated. So we set up our two fractions, and now our last step to get rid of the 4.6 is to divide by 4.6. What's 138 divided by 4.6? 30. All right. So our x value, our missing side, we get 30. Okay. Okay, flip it over, please. On the back, coordinate dilation. Now this is what we're doing, because remember yesterday we've been talking about coordinates. So on a coordinate plane, the center of dilation is the point around which a figure dilates. When the center of dilation is the origin, the new coordinates are found with the rule. Okay. So K is a scale factor. So if I have K scale factor, it's going to be Kx and Ky. All you're doing is multiplying the x and the y by the scale factor. That's it. So while yesterday we were doing switches and signs and adding and subtracting, today for dilations we're multiplying. Okay? Multiplying makes it bigger or smaller. So, Example 1. Draw ABC with vertices 9, 6. Let's do that. 1, 2, 3, 4, 5, 9. 1, 2, 3, 4, 5, 6. And then B is negative 6, 0. And then C is 6, negative 3. And it says we're going to dilate it by a scale factor of 1/3. Okay? So, I'm going to take all those numbers and I'm going to multiply every single number by 1/3. Now, hopefully you know this, but multiplying by 1/3 is the same thing as dividing by 3. So, can we divide every single number by 3? Okay? So, 9, 6. So, if I divide 9 by 3, and if I divide 6 by 3, what am I going to get? 3, 2. Okay? So again, all I'm doing is I divide by 3. So let's do the same thing with B. So negative 6, 0. Negative 6 divided by 3 is negative 2. And then 0 divided by 3 is still 0. Okay, and let's do the same thing with letter C. We got 6, negative 3. So 6 divided by 3 is 2. Negative 3 divided by 3 is negative 1. So can you multiply can you plot those 3 points? So 3, 2, boom, A prime. Negative 2, 0, boom, B prime. 2, negative 1, C prime. And doesn't that look like the same exact shape, but a different size? Smaller, right? So all we did was multiply everything by that fraction, which really just means we divided by 3. We got our new points, okay? Let's do one more, and I'll let y'all work. Example 2 says, so yeah, this Marrero wants me to say this again. I don't know about 3 times. But y'all know 1/3 means dividing by 3. If you don't know that and you don't believe me, then don't believe me. What you're going to have to do is do 9 times, try this again. 9 times 1/3. You can do it that way. It doesn't matter to me. But 9 divided by 3 is the same exact thing. Okay? So you could take every one of those numbers and times it by 1/3 if you want. Okay? So I don't want you to be confused. We're multiplying by that fraction, which means dividing by the denominator since the top is a 1. So, example 2. What is the scale factor of dilation from ABCD to A prime, B prime, C prime, D prime? Okay? So they want to know what is the scale factor, okay? From here to there. So remember, from the original to the new one. So, which one is the original? The big one or the small one? What do y'all think? The small one, because it has no little apostrophes on it, okay? You always start at original. So ABCD on the inside. Okay, here's my original. So all I need to do is find one side link. Let's do that. AB, I can figure out AB. That's 1, 2, 3, 4, 5, 6 units long, okay? And then, let's find my new is all the primes, the big figures. See, this thing dilated and got bigger. So, let's find A prime, B prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Look at that, okay? Did I count that right? I did. All right. So now, what over what? 15 over 6? Or 6 over 15? What's it going to be? So it's always new over old, because to know the scale factor, you must know, and over O, right? So the new, the primes, is in blue, 15. Over the original, which is the smaller one, 6. Can we reduce it? Yes, we can. 15 over 6 reduces by 3. What do we get? 5 over 2. Very good. And leave it as an improper fraction, that's fine. Last one, letter B. What is the scale factor of dilation from, and notice, same question except everything's switched. So guess what you do? Flip that fraction, okay? This time, they're going from primes to not primes. So your n over O is going to be from big to small, okay? So your new one is small, 6. Your original is big, 15. It reduces to 2 over 5, okay? So, there is an assignment on this after you finished yesterday's assignment. I really want you to spend time finishing yesterday's assignment, okay? And I'll just tell you right now, yesterday's assignment, you don't have to do the last page of it. You can. It's up to you. Okay, but the main thing I want is the front and back of the first page and the second page. So you need to have out yesterday's assignment right now. Go ahead and get it out. If you weren't here, you lost it, or some other excuse, it's over here in the back in the blue bin, okay? But I do want y'all working on that for real, using your notes from yesterday. And if you've lost your notes, I got extra copies in the blue bin. So let's go ahead and get started on that, please.